First, we will learn about philosophy of mathematics education. As we know, mathematics education, understood in its simplest and most concrete sense, concerns the activity or practice of teaching mathematics. So, philosophy of mathematics education concerns the aim or rationale between the practice or teaching mathematics. And in more general perspective, it can be said that philosophy of mathematics education has aims to clarify and answer the question about the status and the foundation of mathematics education object and methods. That is, ontologically clarify the nature of each component of mathematics education and epistemologically clarify whether all meaningful statements of mathematics education have objective and determine the truth. We know that teaching mathematics is too difficult because our students find learning mathematics is difficult too. As teachers, some of teachers generally find it easier not to change their style of teaching, which they have probably developed over a period of increasingly successful year in a school. Teachers may hold a very firm views on a particular issues in mathematics education, but at the same time accept that very different, even completely contrary views may be held by a college in the same school. There are those who dispute the term mathematical education and educational mathematics, but we will not question which one is more correct. The most important is philosophy of mathematics education focuses more on educational process in the field of mathematics. But if we ask, what is mathematics education? According to Wayne, mathematics education is a study of those aspects of the basic nature and history of mathematics and psychology of learning and teaching that will contribute to the understanding of teachers in their work with students, together with study and analysis of school curricula, principles of teaching and learning, principles that underlie the development and practice of their use in classroom. The next one is ideology of mathematics education. Ideology of mathematics education covers the belief system of the way mathematics education is implemented. The difference of the ideology of mathematics education may lead the differences on how to develop and how to manage the knowledge, teaching, learning, and schooling. Ernest has identified 4 components of the ideological effect to mathematics education. First, there is the reconceptualization of knowledge and the impact of the ethos of managerialism in the commodification and fetishization of knowledge. Second, there is the ideology of progressivism with its fetishization of the idea of progress. Third, there is the further component of individualism, which is in addition to promoting the call of the individual at the expense of the community, also help to sustain the ideology of consumerism. Fourth is myth of the universal standard in mathematics education research, which can delegitimate research strategies that foreground ethics or community action more than is considered simply in traditional research item. The next one is the foundation. We must know about the foundation about mathematics, right? The foundation of mathematics education search the status and the basis of mathematics education. As we know that mathematics classes that student needs in order to acquire the ambitious knowledge and skills required in today's world are significantly different from the mathematics instruction many of us remember and classes that many of our children experience. So, in order to assure all students success as worker, democratic citizens, and lifelong learners, mathematics education should teach children how to solve both routine and non-routine problems. A routine problem requires a student to use at least one of the 4 basic arithmetic operations to solve a problem that is practical in nature. But a non-routine problem is concerned with developing a student's mathematical reasoning power and emphasize strategies rather than practical application in mathematics, right? The next one is we learn about the nature of mathematics and school mathematics. We must know that mathematics ideas comprise thinking framed by markers in both time and space. Further, mathematical thinking is continuous and evolutionary, whereas conventional mathematics ideas are often treated as though they have certain static qualities. The task for both teachers and students is to weave this together. The school of mathematics is defined and its implication to teaching by following, right? First, mathematics is search for pattern and relationship. So, mathematics can be perceived as a network of interrelated ideas. In this one is mathematics activities help the students to form the connection in this network. The next one is mathematics is a creative activity involving imagination, intuition, and discovery. Creativity in here lies in producing a geometric design, in making up computer programs, in pursuing investigation of a mathematical problem, in considering infinity, and many other activities. In this one, teacher may help the student by fostering initiative, by originality and divergent thinking, by simulating curiosity, and etc. The next one is mathematics is a way of solving problems. Now, mathematics can provide an important set of tools for problem in the main, on paper, and in a real situation. Students of all age can develop the skill and the processes of problem solving and can initiate their own mathematical problems. Teachers may help the student by learning mathematics by providing an interesting and stimulating environment and do many things and do other interesting things. The next one is mathematics is a means of communicating information or ideas, language, and graphical communication. In this one is we can do by talking, by recording, and by drawing graphs and diagram. And also children can come to see that mathematics can be used to communicate ideas and information and can gain confidence in using it that way. So teacher may help the understand to learn mathematics by creating opportunities for describing properties, making time for both informal conversation and more formal discussion, encouraging students to read and write about mathematics, and following and supporting the diverse culture and linguistic background of all students. The next one is the value of mathematics. In the contemporary times, the mathematical backbone of its value has been extensively investigated and proven over the past 10 years or more. We know that value is a phenomenon or concept, and the value of anything is determined by the extent to which it meets the intent of its meaning. Now, there is 4 dimensions about the value of mathematics. First, value of its meaning. Second, value of its uniqueness. Third, value of its purpose. And fourth, value of its function. 4 dimensions of value are always referred to as some concept like intrinsic value, extrinsic value, and systemic value. The next one, we learn about the nature of students. We must know that understanding the nature and characteristic of young student development can focus effort in meeting the need of the student. You can identify the nature of student by in terms of some term like their intellectual, their social, their physical, their emotional, their psychological, and their moral. Young learners are curious, motivated to achieve with challenges, and capable of problem solving and complex thinking. There is an intense need to belong and be accepted by their peers while finding their own place in the world. They are engaged in forming and questioning their own identities on many levels. Students may mature at different rates and experience rapid and irregular growth with bodily change causing awkward and uncoordinated movements. In terms of emotional and psychological, they are vulnerable and self-conscious and often have mood swing. Like in case of moral, they want to have an impact of making a world a better place. The next one is the aim of mathematics education. Now, philosophically, the aims of mathematics education straight from the movement of back to basic of the arithmetic teaching, certification, transfer of knowledge, creativity, up to develop students' understanding. So, the purpose of mathematics education should be enable students to realize, to understand, to just utilize, and sometimes also performs the application of mathematics in society. The next one is we learn about the nature of teaching learning of mathematics. We know that there is so many ways students to learn. Some students learn best when they see what is being taught, while the others process information with auditorily, or many will prefer movement or touching to make the learning process complete. So, the best approach to learning style is a multisensory approach. This type of experiment allow children who are primarily kinesthetic or motor learners to be able to learn through touch and movement. Also, it allows the visual learners to see the concept that being taught with by teachers, and auditorily to hear and verbalize what are being taught. Specifically, Paul Ernest elaborate some issues of mathematics education as follows. First, in mathematics pedagogy, problem solving and investigational approach to mathematics versus traditional, routine, or expository approaches. B. Technology in mathematics teaching, or second one is technology in mathematics teaching. The next one is mathematics and symbolization. And the next one is mathematics and culture. The next one is the nature of teaching learning researches. Now, in order to provide lessons that are both engaging and challenging to each individual, it is necessary to know the student as people. Each individual will come to our class with their own set of abilities, our set of modification, attitude, goal, and cultural background. So, getting to know these various facets of our student will allow us to excel as teachers, because we can tap into their tailored research and knowledge to make the classroom more interesting, dynamic, and personal. Establishing a familiar bond and some trust between us and student, as well as among the student itself, contribute to a safe and caring learning environment. We must learning their interest, their activity, that they enjoy, their academic ability, their weakness, and then it's important in order to differentiate learning in a classroom with students of various ability, various motivation, various weakness, or some of their motivation, like their expectation. So, related to the research of teaching, Ernest suggests that due to the learning should be active, varied, social, engaged, and self-regulating. The next one is the nature of assessment. I think some of us maybe already know about assessment, right? Traditionally, assessment had been concerned with assessing the student's production of correct mathematical statement as evidence of a broader mathematical understanding. An alternative of this place emphasizes on the story told about the event of mathematical activity. So, in assessing, we seem at first to be caught between, on the hand, working with a style of mathematics where we are set a file of mathematics as if devoid of humor, and on the other hand, speaking the mathematics as a depth interpretation of certain style of human activity. I think that's all that I can explain about the chapter. The second chapter is a philosophy of mathematics education. For all of my mistake, I feel so sorry about that, and I hope I can be better in the next chapter. Thank you and good day.